Good afternoon, everyone. I hope you're doing well. Um, Obviously, not the best circumstances, but here we are. Welcome to our first kind of online session, if you want to call it that. Um, for today, I'm going to do a little bit of a recap, and what that is going to look like is I'm going to take you through an example, highlight some things on a project, which will help me and you see how we're integrating submission part one of FAM into our part two items now that you're busy working on. So things like from your bill of material, how do you get into the assembly chart? How do you get creating the production routings? And then from there, how do we build that into the operation process charts logically and step by step? So I'm going to share my screen now. Let's do this side by side so you can see my face, and then you can then see. Okay, so what you should be able to see now is the screen of an example project. It's not really important what what the product is. It's more just to give me an example to show you. So you guys would have done this already, the exploded view. So you have these things, part numbers, etc. As I said, don't pay too much attention to the marks or the marking that you see here. It's just to give you a better idea of what you might expect and how to use that into your own design. So you'll have parts number 1 through to 12 or 20, whatever it may be. And here's your bill of materials. So hers has 12 parts and manufacturing a few of it. You can see there she doesn't manufacture enough parts, so that's one of her feedbacks. But for now, I'll just show you quickly through her drawings. So you can see, okay, here's where I got my parts. Maybe you see here some sub-assemblies that she's missing. And so it is also just to show you that you can continue with your assembly chart here. With even an incorrect one, we'll just add that to you. So if you look at her part number 1, it's the fan stand or the frame, or typically you'll have a base in many of your guys' parts. And 2 is the fan speed adjuster, and 3 is the fan cover, then the blade, wheels, handle, nuts, cables, bolts, blade cover, power supply, etc. So already there you can kind of see how she lays it out, that everything will start to be built on top of the stand. So that's important to note for the assembly chart. Okay, so first things first, in submission 2, you do need to submit your parts list again. So if you would have revamped it or renewed it from the corrections, then it would be the new one, and production routings. So as you see here, I'm just going to zoom in a bit more. This is a typical production routing, very simple. It's got the product name, the part name, which must link directly to the part number as well, so it must be exactly the same. And you can see there it's fan stand number 2 is I think the incorrect name, because she doesn't, oh no, she does use fan stand 02. Okay, so that's a good thing to note. The date, any date, and then operation number will go over here. And as we said, it to be in 10, 20, 30, 40, 50, 60, 70 in whole numbers. And then the description of the operation. Now remember, this is all the manufacturing operations. It's anything that adds or takes away value from or material from your product. So as you can see there, measuring and marking, and you'll see this repeated. That's step number 1 on all of it, or most operations. And the machine is the scriber and tape measure. So this is the first operation here, as you can see. You'll give the description in the middle column and then the machine. It's important for your machine spreadsheet on the next requirement. So measure and mark out with the scriber. Part number 2 is you make the face. So you surface grind it to make it smooth, essentially. I think that's what it is. And then you will cut the material into a specific size with she said with a milling machine, but you can have it with any cutting tool. Then you're going to file the edges as operation number 40 or 4. Then you're going to do some painting, 50, drying, 60, and then that's with the drying machine. And then you're going to cool down and clean. That's one operation, even though it's 2 steps in the cooling machine. And then the last process is the inspection, but this is not an operation. So, it's not counted as your operations. So it's 7 operations for the first part. And you can see she repeated it here for every single product or part that she designed. So as you see, it's a spreadsheet and she's production routing number 2. And I'm not going to repeat it, but it will be slightly different for a different material. So what you can do is you can maybe put the material there for me. That would be good reference point so that I know, okay, is it wood? Is it steel? Is it aluminium? Because then you can also link with the operations. Are we painting steel? Maybe not. Maybe it's plastic, maybe it's wood. Or are we de-rusting it, etc. So here you can see her part number 2 has 7 operations. I'm not going to go into the details, but you can see there's a good variety here because she's there's some threads, tapping machine, nibbler machine, painting machine is the same. I'm going to scroll to the next couple of pages so you can see how she did it. The fan cover, part number 3, fan blade, a rolling machine, welding machine. There's a bandsaw, so you can see her nice variety that she used here. And I also purposefully chose a project that you could see some mistakes that you might potentially make. So you'll see some mistakes pop up here, and there's nothing wrong with that. You can see over here, she's got quantities now. For the wheels, she's got 2 quantities. That comes from your parts list. So if you look over here, she added that in a little bit later. So that's something you got to be consistent about. If you have a quantity, put the quantity in all of your spreadsheets. This is a template that you and your team can create and distribute. So have the template nice and good and consistent with the material, with, the quantities, dates, everything as it should be. I'm going to go now past the production routings into the third requirement for part submission 2, which is a manufacturing spreadsheet. It's the machine processes. So each part has that same number and the part name. And then you're going to have the machines that you set or what you've said in your project as machine number 1. That's going to be exactly the same from your routings. So your production routings dictate this order. So you're going to have 1 scriber machine, 1 surface grinder machine, 1 milling machine, 1 smoothing machine, and etc. etc. We go 1, 1, 1. So there's only 1 in this production line, because again, this is the machines that you need to have your production line run well. Okay, so I hope that is very clear. As you can see here, her wheels, part number 8. So that's a little mistake, and I'll tell you why. I'll show you because I'll go up to the wheels. There, that's part number 5. So she's changed the part number, a very critical error, which I don't want you guys to make. And if we look in more detail, there's a measure and mark out with the scriber. So there's the scriber machine. And then she's injection molding, cutter, design machine, lathe machine, polishing, cooling. Okay, so I'm going to try and remember that for us. Scribe, inject, cut, design, lathe, polish. Okay, so the machines are as follows for the wheels. Scribe, then there's cut. Okay, there's a cooling machine. Oh, no. So this is, oh, you see how she continues on the next. So this is cut off on this end, so that's incorrect. So it's difficult for me to follow. So please have it on one line or one page. Don't have it spill over to the other side. because now I must go and look 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, cutting machine, that's correct. There's injection molding machine, then the lathe, design machine, polishing machine. Okay, so that's correct there. And then you can also see how she doesn't include her inspections, because that is not a machine process. It's not a machine or a machining operation. Those are all inspection operations. So from this machine process chart, or even the operation process chart, which you must also do, you can calculate the amount of operations required. So here you can see she's cutting it very fine. Her requirement, or the requirement rather, is to have 50 operations. And she's got 50 on the dot. So it's either very well planned, or it's very, very on the limit. So another, let me just zoom out here. Another mistake of hers is she doesn't have the operation process chart. She just has the machine processes. So you would need to duplicate this to create another chart, which has only the operations. And now these are the operations over here. If we look at the wheels, there would be a measure and mark out operation. There would be an injection operation, cut and make circular shape operation, design the wheel, turning, etc. Exactly the same look, but the operations is what you would need there. So not the machines, operations. So it's both. You need the machine processes and the operations. Just a very important note there. So it would look like that. Then the third requirement is for you to state your production style. So here she's got line layout, but you need to actually name it. So there she's made a mistake of like showing us, okay, it's line layout, but the layout doesn't decide what your production style is. And yours is high volume, low variety production style. So that's just what you need to type. You can have this image if you want. You also don't have to. You can just say the production style is, as I said there, high volume, low variety, or you can even say single item. And so it's a production line style, or production line layout, with the production style being, boom, the name, like the name of it. Okay, and now we get into the assembly chart. So that's kind of the easier things. And so here we will have the example of assembly chart. So she starts with her part number 1. I would suggest, if you don't know where to start with number 1, because it's normally your base or your frame on which you build. And then whatever you add to it, like for example, she's put the fan speed adjuster with the power supply and the switch as a sub-assembly. So that those three components or parts get added to a sub-assembly, and that's how you have to do it. Because if there are 3 parts going into one, you need to say that it's a sub-assembly of assembly 1. So if it's also in the same line, so let me zoom in a bit so you guys can maybe see the screen better, and give you a little highlighting here. There. If it's in the same line, you would go assembly 1, but on the left, you'd mark it sub-assembly 1. I'll take you through what on the same line is for 2. Then she moves down to assembly 2, which has a second sub-assembly. So sub-assembly. So this is also incorrect. It's SSA, sub-assembly. So there's a sub-assembly of a fan blade and the fan blade cover. So if you remember her diagram, there was a blade of a fan and a blade cover that goes on top. And then that sub-assembly 2 gets added to the fan cover, which is a sub-assembly 2. And then the fan cover unit gets placed onto the fan stand. So that now it's a complete fan cover with a blade and all of those things, and it's put onto the stand. Right, I hope that makes it clear. I don't have a little image of it on the side, but I think you guys can follow that fairly simple example. Then this assembly 3, she puts the handle on. Then she would put the wheels on. So these are not operations. These circles here are not operations. In your assembly chart, it is the part number, and this part number links directly or exactly to your parts list, your bill of materials, as well as your production routings, as well as your drawings. So all of these are her components, and you are showing me, or you're putting together these parts to make the product. Then she's got some bolts and nuts. Further down with the sub-assembly 5 into assembly 5, and then the cable goes as the last assembly 6, and then assembly 7 is the final assembly on your production line. All right, so I'm going to move on now to the next requirement, which is the operation process chart. So now the big image looks like this. Let me zoom out. So this is definitely going to be on an A3 page, for example. The assembly chart here above, assembly chart can be in A4. It is generally smaller, so it will fit clearly, and I can clearly see on a A4 page. She's printed it out on an A3, which is fine. You can do that too. It's up to you to decide. I just need to be able to see it clearly. So if you look at this, that is now an A3 page as well. And the text is very small, but I can generally zoom in and I'll be able to find it. So I'm going to take a step back now just to clarify. Assembly chart you do first, because the operation process chart now integrates your production routings, which has your operations, and it overlays it or adds on top of the assembly chart. So you can see here on the left-hand side is all the assemblies, as well as then also your part numbers. So if you look here, your individual parts, so the fan stand with each and every operation. She's lost a bit of marks here because of the one being in just on the line. So what I want you guys to do is have it on the side slightly to the left so you can see so I can see the numbers. So her numbers are, again, like I said, wrong. So you're going to do 10, 20, 30, 40, 50, 60, 70, and then 10 for inspection. And the symbol for inspection is a square. So operations process chart, you're going to take the operations and overlay it on a process chart. So each and every part number that you manufacture from your routings must have one of these, or it must have all of your operations listed and put on a chart. The chart which you use is referenced from your assembly chart. How you put this, how you assemble it together. So her fan stand was part number 1. There's part number 1. I should be able to see part 1, fan stand, and the name should be exact. And then you list all the operations. So you can see the ticks here. I take your routings and I double check and I cross-reference it. Did you measure first? Is the second step to make the face? Is it cut the material, file the edges, paint, dry, cool, clean? So if I go look for the wheel, which I'll show you how to do, it should be exactly the same as well. So remember from the assembly chart, 1 got linked to at A1, assembly 1, but there was a sub-assembly. The switch which she bought, you can see there's no operations here. So she bought this switch and she bought the power supply. So that gets added to, if I scroll to the left, the fan speed adjuster, which she is making. So this should have 10, 20, 30, 40, 50, 60 operations, and then drying 70. And now you can see here there's some mistakes because she's made the number wrong, or something is overlapped here, and you can't really see what the fan blade covers number is and how that works. So that's something to be mindful of and where you might lose marks. So there's no inspection here. So is that the same as up above? I would check the top routing to double check there. And so sub-assembly 1 goes to assembly 1. Then assembly 2 is consisting of a subassembly and a sub-subassembly. So remember how I said she made a mistake there? So your SSA, sub-subassembly 2, and on the assembly chart, she had sub-AA. So that's a little mistake there. But all those little mistakes add up. So the fan blade and the fan blade cover get connected, and then from there it goes to the fan cover into the subassembly 2, and then finally with your assembly 2. Your assembly 3 consists of now putting on a handle. Here's the handle. Then you go down again, and here's the wheel. So now I'm going to look for the operations here. And as you can see, on this wheels, there's a mistake, and I see something that the previous marker did not pick up. So if we look at the wheels, part number 5, measure and mark out, operation 1. That's good. Inject, make a circular shape 3, design the wheel. That's part number 4. Then you turn it. Now it's back to polishing and finishing, part number 4, operation number 4. So that's a mistake there. Then it's cooling down again. It's very strange. So something's going on here, and this should be a cross mark there. So that's the level of detail I want you guys to think about for each and every part in your operation process chart, because this is the foundation of your factory. From here, everything gets laid on top of this in more detail. And so the wheels get assembled here on assembly 4, and you can see then it's just the bought components or the purchased components. So all of your purchased components don't have a manufacturing process because you buy it in, and then there's a little inspection if you want. And so you see the nuts and the bolts. You don't have to inspect them. You can just add them in as a subassembly. Let's say you're fastening the TV screen or your little CPU, but you have to do it with a bolt and a nut, for example. Okay, so that is, you will conclude then with assembly 5, assembly 6, assembly 7, exactly the same as above in your assembly chart there, assembly 5, assembly 6. So you can see there nuts and bolts, the part numbers will link up. All right, so if you have maybe a sub-assembly, so you can have another sub-assembly down here for sub-assembly 2, then that's also fine. You're just going to choose. If you have, now this is an example, if you have 2 sub-assemblies which are at the same level, so sub-assembly 2, and you had another, let's say you had a different fan blade cover and maybe a screen that you had to attach, then you would have sub-assembly 2A and sub-assembly 2B, and you take the fan and the screen and you connect that into sub-assembly 2. So the A and the B, if you had another one down here, you would call this one sub-assembly 2B. Let me annotate that quickly for you guys. So if I draw this for you, I will try and sketch something. No, it doesn't look like I can sketch for you for right now, but it would be a circle, and then the parts would be there, and it would be sub-assembly 2B on this one, and this one would be 2A. Okay, let me move on to the next requirement. So here comes your process charts now, and I think I did spend a lot of detail on this last time, but I'll just touch on it again quickly. We will have in your process chart, again, this template can be reproduced, template can be made, and you can share that template out with your team members. The detail in here will be, of course, different for each and every one of your products. So you can list the activities, and this is exactly what you had from work study. So it's nothing new. You can, of course, copy that template over there as well. So you're going to have the part name. You're going to tell me this is part number 1. And again, the name must be exact. Then here are your summary parts, which has now all the 5 operations or steps within your work study environment. So operation, I think this one is Inspect, yes, that's the inspection. Transport with an arrow, D for delay, and then triangle is also storage. So it's so it says there, get material from storage. It'll all come from storage. It doesn't just manifest from nowhere. So each of your process charts will have a retrieve item from storage or receive raw material from stores, something like that. Then it will be transported, move the material to the bench or to the workstation one. Then you will mark and measure. And these operations now will be exactly the same. So if you can see there, it's 1, measure. 2, make the surface material flat. Then 3 is cut the material. And you're moving it from one workstation to the other. I want you to see how the arrows are moving. That's also important here. You're going to file the edges as number 4, paint, dry, and then cool and clean. So note here, I'm going to take you back to the production routings, and I'm going to whiz up quickly to page number, I think it was 40. No, it's a little bit further than that. Yeah. So that's the bill of materials. Here's your production routings. And it is exactly the same on the process chart as it is here in your routings. Measure, make the face, cut the material, file the edges, paint, dry, cool and clean, inspect. So can we confirm that? Let's go back. Part number 1, the name is the same, and here it is. So you see the level of detail and duplication, consistent thread, golden thread streaming through. And she does this for every single part. All right, so that's what you guys are going to do. Part number 5 is the wheels. So we know the wheels, and you see there why it is a mistake, because in her operation process chart, she had these 2 operations as 4 and 5 again. So 1, 2, 3, 4. She had designed the wheel, turn it with the lathe machine, polishing, and then cooling down. Okay, and I'm going to move through. So she's listed all her manufactured process charts. Now the related flow diagrams come in, and she's designed this very beautifully on SolidWorks. So you see here, it comes from a receiving stores. That's the triangle there. And the arrows you will duplicate again with the operations. So you must have the symbols relevant. So if the arrow dictates transport or movement, you're going to put transport number 1. Actually, transport number 1 is over here, because according to your process chart, you went from stores or storage, transported it to the workstation. Then you had the operation 1 scribe with the operation 1, and the machine is also here. So it's operation 1, scribe and measure. Then it's operation 2 with the machine, surface grinder. 3, there you can see 3 with the milling machine, 4 with smoothing, 5 with painting machine. So you want to show me, or I want to see the symbols, and your numbering must be very clear. So you can see here, there's the transport is done on the conveyor belt. So that's not a problem. Your conveyor belt can be a transport. It is a transport. And then the last one is to shipping. So transport to shipping, and then the storage is over there. And again, the part number is on this item. The part name is on this related flow process diagram. So the flow process diagram just duplicates duplicates whatever it is that you have on your process chart in a graphical form. So it's a picture to give you an idea of how each of your production lines are going to look. So if you have 12 manufactured parts, you will have 12 production lines, and you will have to show me 12 related flow diagrams. And you can see here how she will do it here for us. Just not that image. I think it's scanned wrong. There's the fan cover, and we can go back to the wheel. Part number 4, part number 5. So here we go. You see, here's a spelling mistake again. So that would be a very big no-no for me. So please, guys, make sure your spelling is correct and accurate. And then your numbering is also accurate. So there's receiving, transport, your operation 1, 2, 3, 4, 5, but I want to see the symbols as well. So the circle, arrow, circle, arrow, circle, arrow, triangle. If you have a inspection, I want to see the inspection. So here it is, inspection. So again, all taken from your production routings, from the process chart, and further down, etc., etc. Okay, I'm almost done with the repeating of the lecture, but I think it's important now, getting to the final stretches. So now you can create again a manufacturing flow process chart. So this is now taking your operation process chart and expanding it further into all of the flows and how the material will move, how the parts will get put together. And it's a triangle at the store, so I can see that the text is smaller. And so here it's important for you to make it clear to me and print it out well. And the numbers must be included as well. So here, I wouldn't be able to see this if it was printed out, I don't think. This is very important that this is printed out in A3 or even A2 if you can. So at the stores, then it's transported to the workstation, then it's measure and mark out, surface grind, transported to the surface grinder, then you make the face, then transport to the milling machine, cut the material, transport, file the edges, transport, paint, transport, dry, transport, cool, transport, inspect, transport to subassembly or assembly. So there you are. That is the fan stand. So even for the bought items, they come from somewhere. They come from the store, then to inspection. They get transported to it. Otherwise, how does it move? Again, this is now where FAM starts. How do you track your material? How do you track the flows? Where does it come from? Where does it go to? How many transports? How many touch points, etc. So the switch comes at the store, and then from the store to inspection table to the sub-assembly. So it's not the assembly or to the sub-assembly station. And again, you can see that she repeats it for every single component. So all of the flow processes of all of your parts. So let's go have a look at part number 5, the wheels. You see she's typed it correctly there. Okay, so here we go with from the stores to the workstation, measure, to the injection, molding, inject, to the cutter, cut, to the design, to the lathe, turn, to the polish, 6, to the 7, to cooling machine is 7, cool down, to the inspection is 8, and then inspection is the first inspection. And it's not the second, as you can see here, she's got to the assembly. It's not the second transport. It is the 9th transport. So the numbering is also important here. You need to really pay attention to your numbering, and she's got them all wrong, it looks like. Transport to assembly 2. Okay, so these are the things that will give you good marks if you have the detail-minded orientation to it. Okay, so now the master flow patterns. As you can see here, she has designed her factory. It's just the general flow, guys. I'm not really concerned about where exactly the rooms are, so you don't really need to do too much into that. I just want to see, okay, where is it coming in? The flow of material. So you can see there's a kind of a nice straight line to there, and then the flow goes down, and then across, and then out. Right, I would have put the out going this way, but that's, again, it's up. This is the design flow number 1. The design flow number 2 must be, or you must have 2. On your rubric, it says a minimum of 2. And what you're going to do here is you're going to compare, evaluate. And I'll record a separate video on that, because I think it's kind of a lecture on itself, and then you have it. And so these 2 layouts or general flows, you're going to rate against each other or evaluate. So you need to have kind of a good one, or good one, and a not so good one, so that you can kind of compare. So if you are making a choice, that you can kind of choose the better one, the better version for yourself. Okay, so here's her flow number 2. It goes in the middle, across, down, and then you can see the material splits, and it like splits and comes around, and it goes to the middle again. So it's quite convoluted, and you want to go down there and then out to the side. So that's her second design. And then she's got a material flow design evaluation sheet, which looks like this. So what you're going to do is you are going to have another rubric. It's not a rubric. It's a template. And you're going to have these different criteria. So each of these criteria have a certain weight according to it. So like a weighting. So if you think about how important something is, it has a higher or more important weighting. So optimal flow, material flow, that has a weighting of 10, and then a score of 10. So she's scoring design 1 a 10 out of 10. Design number 2 doesn't have such optimal flow, so that's a 7 out of 10. And you take the weighting and you multiply it by the score. So you're rating your own designs for the case of you want to choose the best one that you want to use. So the next criteria is continuous flow, and she's rated the first one a 9. Sorry, the weighting is a 9. So all of these here are the weights, the weightings, how important it is out of 10. And then the scores over there. Please don't make everything out of 10. So you can see she has 3 very important things, but you can't have more than 3 important weights. It's just, there must be some discretion around what's important, what's most important, what's mid importance, what's of low importance. So you need to please just use your discretion there. So you can see she's got a couple of 9s, a couple of 8s. Minimum backtracking is 6 of 6 importance, and then the minimum walking between, that's low importance there, you can see. So 3 out of 10, 3 multiplied by 3 is equal to 9. So it's a weighted average. So the weighted score then gets a total, and then you can divide that by the number of criteria if you want, but essentially the 2 numbers, the 2 designs will have a different score. So 581's score is for design 1, and design 2's score is 480. So then you need to decide, or tell me what your decision is, because that's part of your marks. Tell me which design you are going to go with. From there, that leads us into part number 3. So this is the end of your requirements for submission 2. And yeah, it's actually been, or it's gone, I've been able to go through it quite quickly. You can give me some feedback, and maybe next week we'll break down exactly what you want more help on. We can use your particular project or the team's project, for example. I mean, or the team can present a project within there, and we can take that apart. So the last thing to do is to, as I said, choose the design. She went with design number 1. And also just make sure that you choose the one that you like. So she obviously liked this design 1 over here, right? So she wanted to kind of use this one in her final project. So that's what she said to me here, and that's what you have to do. So she doesn't want to use design number 2, and so she's chosen design 1. Okay, thank you guys. This is this next page is not really relevant. It's for submission number 3. So that concludes this little lecture. Asynchronous in nature, I know, so you don't have the opportunity to ask questions, but please don't feel like you need to. I think you can use this and get going with your submission 2 if you haven't already. Again, good luck. Thanks for listening. Thanks for your time and attention. And I hope to see you guys soon next week in class.